Good morning, and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video I want us to explain example 9 of binomial estimation, and we are on Pure Mathematics 2 page 71, whereby we want to learn about binomial estimation. And under 4.5 we are told that in engineering and sciences it is often useful to find simple approximations for complicated functions. And one thing that is very clear in that statement is that if x is less than 1, then x raised to power n gets smaller as n increases. I will explain that. But of course, when a fraction is raised to a higher power, it becomes a bigger number, it becomes a smaller number as the power, of course, increases. For example, if a half is squared, we have a quarter. If a half is cubed, we have an eighth. And of course, an eighth is smaller than a quarter. That is exactly what this means. We can know that sometimes if x is small, you can sometimes ignore large powers of x to approximate a function or estimate a value. For example, just like what I've said, if a half is raised to power 2, then we have a quarter. If a half is raised to power 3, we have an eighth. If a half is raised to power 10, then we have a very, very small fraction which can actually be ignored in case we are looking at approximation. And in example 9, we are told that find the first 4 terms. In example 9, find the first 4 terms of the binomial expansion in ascending power of x of 1 minus x over 4 raised to power 10, the first 4 terms, before we even come to part B. And the value of n is 10, so the first coefficient is 10 NC0, 1 raised to power 10, and of course minus x over 4 raised to power 0, which should be ignored because it's just 1. So 10 NC0, 1, 10 plus the second term, the coefficient is 10 NC1, 1 raised to power 9, and now the second term minus x over 4 raised to power 1. Remember, 9 plus 1 should give us 10. 10 plus 0 was to give us 10. 8 plus 2 is giving us 10. 7 plus 3 is giving us 10. That is as far as the second term is concerned. The third term, the coefficient is 10 NC2, 1 raised to power 8, then minus x over 4 raised to power 2. Then the fourth term, 10 NC3, 1 raised to power 7 minus x over 4 raised to power 3. Please remember, when we employ now the calculator in finding 10 NC1, we have 10. We have 10 NC0, we have 1. 10 NC1, we have 10. Then of course times 1, because 1 raised to power 9 is 1, and then divided by 4, which is negative, then we have minus 2.5x. The same case applies here. 10 NC2 multiplied by 1, of course, divided by of course, when x is minus x is raised to power 2 becomes x squared, and 4 at the denominator raised to power 2 becomes 16. So whatever you will get here, you divide by 16 to give us 2.8. And at that point, we need now to go to the second term. And of course, the next term, rather, not the second term. Let us have the calculator very near so that we can even see how does this become how does this become 2.8? We have 10 NC2, we have 45 times 1 divided by, of course, 16, which is 2.8125. That is how this one comes to be. The third one, 10 NC3, we have 120 times 1, and of course 4 times 3 is 64, so divide by 64, we get something to do with 1.875, and of course you should observe the signs. The second term is negative due to the fact that we have negative x over 4 raised to power 1. The third term is positive because negative x squared is positive. The fourth term is negative because minus x cubed is negative. So we have those 4 terms. Part B of the same question is that use your expansion to estimate the value of 0.975 raised to power 10, giving your answer to 4 decimal places. It goes without saying that using this expansion, or rather this expansion, we should find the value of 0.975 raised to power 10. Then what we need to do is to compare the original expression to be equals to what we are solving. And 1 minus x over 4 raised to power 10 is equals to 0.975 raised to power 10, because this is what we have expanded, and we need to use this expansion to find the value of this. Since the powers are the same, then the same expression free from the powers are also equal. It goes without saying. And at this particular point, we just need to make x the subject of the formula, so that once we get x, we can substitute the value of x here. And when we take this across, it becomes x over 4, which is positive now, is equals to 1 minus, now this one crossing over, 0.975. And this is what we have, 0.025. And of course, to make x the subject, you multiply both sides by 4, and x is comfortably 0.1. X is comfortably now 0.1. Having said this, then x over 4 is equals to 1 minus 0.975, and x over 4 is 0.025, multiplying by 4 both sides, 0.1. That is the value of x. Substituting for x in the expansion. Which expansion? Now, this expansion. We have 1 minus 2.5x, which is 0.1, plus 2.8125 x squared, which is 0.1 squared, minus 0.875, 0.1 cubed. Those are the values of x substituted there. You only need to use the calculator, and your answer is going to be 0.77625. And of course, to 4 decimal places is going to be 0.7763. And now we can comfortably say that 0.975 raised to power 10 is equals to approximately 0.7763 to 4 decimal places. And that is just like it. That is how we can use binomial expansion to solve, to estimate values of given functions and numbers. So again, visit my YouTube channel, subscribe widely and share widely, and let us walk together as we understand mathematics further. All right?